This is question 4 and it's all about integration. So we can see the first question is asking us to integrate this line that we have here between 2 and 0. So if we take a little look at this line between 2 and 0, we're finding the area under the line, or between the line and the x-axis. That's the area that we're finding in this question. That's what it wants us to do. So how do we do that? Well, let's ignore the 2 and the 0 for now. Let's ignore those and let's just integrate it if we were integrating it for any two constraints. So let's integrate x to the power of 4 minus 8x plus 9. And then this dx here, this is the opening of the integration, and this is like the closing of the integration. You can think about it like that if you want to know why we put that there. You don't really use it in A levels too much, but so let's do that. So let's increase the power there. So x to the 5 divided by that new power there, and then minus 8x squared over the new power 2 and plus 9x, and you can put over 1 if you want to. I mean, we don't have to put that there, it's over 1. So that is what we have. That's our integrated form. So let's bring back the 2 and the 0 and let's make some sense of that. So let's go into green, I think. So what can we do? Well, let us sub in 2, our higher constraint. Let's put 2 into this integrated form. So we have 2 to the 5 over 5 minus, and then 8 over 4. You can cancel that out to get 4 times by 2 squared plus 9 times by 2. So what is that going to come out as? What is it going to come out as? So 2 to the 5 is 32, so we get 32 over 5, and then take away 4 times 4, so take away 16, and then plus 18. So this is going to end up being, what is that going to end up being? That's going to be 8 and 2/5, or 8.4. So this is 6 and 2/5, and then this is all together. This is plus 2 here. So you can do that yourself. You don't need me to talk you through that. So then we have our 2. Let's look at our lower constraint there. So we have a 0 here. Put 0 in. Well, we're going to get 0 over 5 minus 0 over 2 plus 9 times 0. This whole thing is going to equal out as 0. So normally what we would do is take this value and say this take away this is equal to this area here. Well, we can do that, but it's 0. So our answer for integrating this area here, this area, is 8 and 2/5, or 8.4, whichever you prefer. Both are equally valid. So next question, hence find the area of the shaded region. So they want us to find the shaded region, this one right here. And the way that we do that, so there's a kind of rectangle that you can see hopefully here with, I know that's not very straight, but here we go. So there's our rectangle there. So the area of our rectangle, so let's go down here for part 2, part II. So our rectangle is going to be 9 times 2. So the area of our rectangle is going to be 18. So that's this whole purple rectangle there. And then we found out the area under the line, so the red area there. We found out what that was. That is our 8 and 2/5. 8 and 2/5. So then, in order to find out this shaded region, we can simply do 18 minus 8 2/5, which will give us 9 3/5, or 9.6. 9 3/5, and that is the shaded region. If you want units, then you can sometimes write square units here, but you know they never order mark for that, so you don't particularly need it. So let's move on to B, pink. B, the point A, 1, 2 lies on the curve. So this curve, this same curve that we have here, this curve that comes down and through there, has a point 1, 2 on it. So it wants us to find the gradient of the curve. So in order to do that, in order to find the gradient, we need to find, let's go down here, BI. So in order to find the gradient, we need to find dy over dx. dy over dx is the gradient. There's just a notation for it. It's the difference in y over the difference in x. All the same thing. So let's differentiate this equation here. What are we going to get? Well, we're going to get 4x cubed minus 8, and then the 9 disappears. So that is what we are going to get there. Let's change to blue. So then what we need to do is put x equals 1, because our x value is 1. So if we put x equals 1 into that, then what are we going to get? Well, 1 cubed is 1, times 4 is 4, so we're going to get 4 minus 8, which is equal to minus 4. So minus 4 is going to be our gradient in this situation. So you just write down, you know, gradient equals minus 4. At that point is somewhere around here, I think, I'm guessing. I don't know, something like that, and then you have that there. And then our last question, find an equation of the tangent to the curve. So we have a point A, and we have the gradient. The gradient is minus 4. So let me scroll down and get some space. Here. So if we go, so part B2 or II. So we have our point A is 0.12, and we have our m, our gradient, which is minus 4. Then we can look for y minus y1 equals m of x minus x1, and then hopefully you know how to plug in these values by now. So this is going to be our x1, and this is going to be our y1, and that's m there, you can see that. So y minus 2 is equal to minus 4 amounts of x minus 1, and then it just becomes a simplification task. I'm going to go, where am I going to go? I'm going to go this way to give myself some space. So y minus 2 is equal to minus 4x plus 4, because we have two minuses, and then new color. What can we do? Well, let's add 2 to both sides to get rid of that there. Let's add 2, so we get y equals minus 4x plus 6, and then you can leave it like that, or you can leave it in actually any form you like, because they haven't asked for it in a specific form. Normally they say, or sometimes they say, we want it in this form with, you know, ax plus by plus c equals 0, but they haven't asked for that on this occasion, so you can leave it in whatever form you feel most comfortable with. So, see you on the next video.